Hi there. This is a video covering the intricacies of our spaceship design for the government. This project took us about 100 man-hours and a lot of ingenuity. Our tour will start inside with the kitchen dining room area.
Our kitchen includes everyday kitchen appliances, such as the microwave, kitchen cabinets, a dining table, and seating arrangements. Our food is kept here in depressurized packages, and our drinking water is kept in what we call water wands, where pressurized water is kept in the staff of the water wand, and with the push of a button, water droplets are released and can be consumed.
And that's our kitchen. Now we'll be moving on to the sports room. The sports room, you can do in here basically all kinds of sports. Basketball, soccer, bouncy balls, really all you need is the right type of ball and you can do anything. In addition to having padded walls for safety, we also have retractable hoops that can be stationed in positions. Basically, you have the Aztecian vertical hoop going for you, or you could do the standard American basketball hoop. And with that, we move into the medical room. Alright, in here we have our cutting edge computers interfaces, which we'll go more in depth with when we travel to the bridge. And we have our operating tables for all your doctoring needs. Connected to the ceiling are our spacious cabinets in which we'll put all of our flasks, distillers, basically anything that has anything to do with chemistry. In addition to our medical needs, there's also these nanopads, which are devices that do everything from analyzing the composition of sediments and air to analyzing what type of microbes are on those rocks and in the air. And now, we will move into the bridge.
The bridge is the center of control for the entire space shuttle. Navigation is controlled here, and everyone has interface with the central computer that is placed in the floor of the bridge. The computer to the left is our communication computer. The center computer is a navigation computer, and this one is our science computer. Our computers are controlled not by touchscreen, but by computer gloves that allow us to use the computers at any distance we are away from them, and that is our bridge.
But that's not all. And these are the cryo chambers. These bulky machines are designed to induce a sort of stasis designed to lower nutritional needs and the aging process. On the outside, we have a veil of holographic shielding for privacy.
So this is one of our exercise machines that will enable our astronauts to work out every muscle in their bodies except for their calf and neck muscles. Some exercises that this machine can facilitate are squatting and bench pressing. The way this is possible is through the cylinders at the center of the machine that require pressure to move the pistons within them. The machine can also be adjusted to accommodate the user's strength and height.
Alright, and from that we move on to the treadmills. The only difference between these and regular treadmills is that these treadmills have a harness to keep you steady and safe. And from that, we move on to the alien cells. Controlled by the central computer, the holding cells adjust to the needs of the creature. The computer controls spacing, water levels, heating and cooling, and nutritional needs. And from that, we move on to the escape capsules. This has all of the bells and whistles. Thermoelectric energy harvesting, 360 angled cameras, first aid kits, waste systems, steam thrusters, life jackets, protective helmets, a food supply and storage, even some genetically engineered plants if you want to start a new life on a new world. They can even be used underwater. And after that trip, we move into the bathrooms.
Our shower includes a compartment where astronaut suits can be placed and we periodically wash. The shower works in that the water from the second cylinder, that is divided into two sections, the top one with clean water and the bottom one with used water that is being filtered, travels through a tube and into a nozzle in the first cylinder, where water is released for cleaning purposes. The water released is then sucked in by a nozzle at the bottom part of the first cylinder that travels through another tube into the second cylinder to be then filtered and reused for shower purposes again. We also made 2 water closets, one for men and one for women. The water closet works precisely for the lack of gravity, in that handles and steps allow you to climb on the water closet and hold on while natural processes occur. The water closet will then absorb all urine and fecal matter and continue on to eject it into space. The toilet paper is there for emergency purposes in case all urine or fecal matter is not absorbed.
Moving on to the sink, which has both hot and cold faucets. With each turn of a faucet, a small amount of water in blob form is released. The user would then take the water blob into their hands and rub their hands with the blob, similar to how one puts lotion on their hands. Now the air blade, after using the sink, excess water may be on one's hands. When the user inserts their hands into the air blade, it will blow rapid blades of air towards the hands, thus effectively drying one's hands. But any excess water that falls into the air blade would be sucked up and then transferred into the water filtration system, allowing for more water to be recycled. Lastly, because dental hygiene is a must, toothpaste will be used, but not your typical toothpaste. This toothpaste will be in tablet form. Chewing on a tablet activates the process. This process involves the tablet expanding as a foamy substance. After reaching all of one's teeth, one can then rinse the foam out.
Now we move on to the water distribution system. The water distribution system is controlled by the central computer of the space shuttle and is placed on a conveyor belt. Through the central computer, the water distribution system supplies water to all necessary areas of the space shuttle, and water is refilled when we stop at space stations and replace the pressurized containers filled with water, which brings us into the water separation system. Our water will be divided into its hydrogen and oxygen components through the mixing of water and a metal complex of the element ruthenium. This occurs through a sequence of reactions and thermal and light-driven steps that breaks the bonds of hydrogen and oxygen atoms. The oxygen separated from the water is used for our breathing, and most of the hydrogen will be used for our engines.
The rack of tubes in front of you is our water filtration system that utilizes the process of reverse osmosis to purify and recycle the water that has been used. The way this is this works is through the membranes within the tubes that allow certain molecules to pass. We can tweak this property to only allow water molecules to pass, restricting all bacteria and any other pathogens to continue. And this is the depressurization hatch. This room is fully functional with equipment needed for a successful spacewalk. First, the exit hatch. The exit hatch is computer operated and has an emergency valve operation. The hatch is powered through electromagnets that gain currency through a small electricity box that is toggled by the computer, or the emergency valve. The electricity box, when toggled, causes a small tube with a metal rod inside to rise up or down, either connecting to a smaller tubes with electrical wires to pass the electrical current, or fall down, disconnecting the smaller tubes to get rid of the current. When the current is passed, the electromagnets activate and they attract to the other magnets on the other side. There are two exit hatches, one in the depressurization chamber and one on the outside of the ship to assure safety. Next, the depressurization vents. These vents have sealed gates inside them which block off the air inside the chamber from going outside into space. When the gates are toggled, they rise open very slowly and the air inside the chamber is drawn out into outer space. This is to assure safety from being drawn out too quickly into space when the exit hatches are opened. Next, the computers. These computers are powered by the ship's central computer, and they are used for getting information, toggling the depressurization vents, and of course, opening and closing the exit hatch. Thirdly, the astronauts' suit holders. These holders have drawers which hold the spacesuits itself. While the astronaut helmet goes on top of the stand, next the sealed metal entryway into the depressurization chamber. This sealed metal door uses the same mechanism as the exit hatch. It uses multiple small electromagnets that gain currency from an electricity box that is toggled by two door handles. Having two door handles assures that the user will have to use both hands to assure safety from accidental openings. Lastly, the plasma guns. These guns are used for hunting and killing unknown animals that can be found in other planets. The guns are set on magnetic racks to keep them from floating while in outer space. Everything on the depressurization chamber is bolted down to ensure that they will not stray from their position when in outer space.
And now, we move on into the engines.
This here is the Orion engine. The way the engine functions is by having a pusher plate launch atomic bombs 20 to 30 meters beyond it every 1.1 second or so. The series of explosions propels the shuttle forward. You may ask yourself, how can you use the bombs safely? Well, the basic structure of the engine consists of two stages of shock absorbers that reduce the impact. The engine has a deflector cone that deflects radiation and other harmful space conditions. The continuous explosions can cause internal structure damage, which is why it has a shield surrounding most of the engine. The engine also has two coolant tanks inside the large part of the engine. The coolant tanks have hydrogen and beryllium that prevent the metal and engine from burning up. With this engine, the shuttle will be moving anywhere from 19 to 31 kilometers per second. Due to its instantaneous acceleration, we have to set a detonation that humans can handle. We decided to use this engine because it helps reduce the time of the voyage to approximately 11 months to land on Europa, Jupiter's moon.
The next engines that we use are a pair of liquid core engines. In these, fuel is converted into high pressurized gas that releases out of the nozzle with a centrifugal force. The liquid core engine has better efficiency in comparison to a solid core engine. Nuclear fuel is mixed with the working fluid It can operate at higher temperatures beyond the melting point of the nuclear fuel. This is extremely important because the efficiency of a rocket engine is related to the square root of the temperature of the working fluid. So higher temperature equals higher efficiency. Reaction time takes place in the liquid mixture itself, heated to a maximum inside a cylinder rotating at high speeds. The max temperature equals the temperature at which the container wall can withstand, while actively cooled by coolants beryllium and hydrogen 2. Engine constructed out of carbon steel, allowing for extremely high temperatures and minimal sacrifice of potential energy. Thus, in the end, the engine will have a high specific impulse, which means a more propeller efficient engine, so less propellant will be needed. And exhaust velocity should be able to reach 19,620 meters per second.
You may be saying to yourself, wow, that is one bulky ship. How is this going to survive re-entry into a planet's atmosphere? Well, after much research, we came up with an ingenious solution: hypersonic propulsion. In succinct form, the way this works is that while the ship enters or leaves an atmosphere, it continually ejects bombs of hydroxide, made from water and electricity, that continually explode, then implode in front of the ship to greatly reduce drag. This allows the ship to not burn up in atmospheric conditions. Now, on to power. How do we keep this ship in space? Using electricity. Most of our power is stored on board, but we also derive power from docking at a space station with its many heat lamps. The ship is lined with a very special alloy that turns heat into magneticism. We then turn this magnetic power into usable electric energy for all ship processes. And in case of an emergency, if the ship is bombarded by space debris, and some of the space debris enters the ship, that portion of the ship is immediately cut off and depressurized, and a special syntactic foam fills that hole left by the space debris quite rapidly. This foam, being light, airtight, and waterproof, serves as a viable encasement. And if you're wondering what these yellow things are, they are very durable flotation devices. They can survive land and water landings.
These here are seismic isolators. The seismic isolators are designed to absorb the kinetic energy that minor earthquakes in the planet will cause. The isolators consist of 3 layers: rubber, lead, and steel. The rubber causes the base to be flexible. Lead is part of it because of its plastic properties. During the time of impact, the kinetic energy is turned into heat and causes lead to deform and reform, preparing it for another impact. Steel is used to cancel out the forces in the vertical direction. Because of the steel, the rubber only moves horizontally.
And that's our ship. We hope you enjoyed it because we worked hard. Bye!